Hi, in this video we'll discuss LangChain intermediate level interview questions. How does runnable parallel instantly speed up your LangChain applications? What runnable parallel does is it fires multiple requests parallelly. Unlike the regular flow where we do sequential calls, like we request for a response, once we get the response, we'll do another call. So we are waiting for one request to complete. If we have like five requests to complete, like it takes uh, time to complete those five requests. But if we are using runnable parallel, five requests will be fired at same time. Once we get all the response, we can continue the flow. In the provided sample snippet, here we have two things: summarize, translate. We are using runnable parallel and configuring these two, summarize and translate. With the same input, we are firing both the requests and it is stored in the results. If we see the output, we got the summary and we got the French translation. What are tools in LangChain and how does agent know when to use them? Tools provide additional functionality to LLMs like searching web, running Python code, or querying databases. When we are creating tools, we have to use precise test description so that LLMs know what the tool about. In the code snippet, we have two tools. One is for getting word length, and the other converts given word to uppercase. We are configuring these two tools and passing the tools to the agent. In our input, we are asking to count the number of letters and transform the letter to uppercase. If we check the output, the LLM was able to use the tools and provide the expected output. Like the artificial has 10 letters and the and it also converted into uppercase. What exactly is retriever and why it is backbone of RAG application? Vector database simply stores the data. The retriever does the actual work of retrieving the data. It usually retrieves the relevant data. In the example, we are creating in-memory vector store and define the retriever. And here, when we ask a question, what retriever in LangChain, here we have the vector database. What it does is it gets the relevant data from the vector database and provide it to LLM and generates the response. Why do we need output parser if LLM already generates the text? By default, output from LLM is text, but in few of the cases we don't need text. We need JSON object or Python object. So what we do is we configure the output parser and pass it to LLM. By that, LLM knows we have to transform those text to JSON or Python object and clean up the extra text. Here we are creating a model and we are expecting a JSON output parser, and here we are passing the model we defined. When we ask for the response for this particular input, it provides the expected output in the JSON format. How can you use callbacks to monitor what your LLM application is actually doing? Callbacks are nothing but they are event hooks and fire at specific moments in a pipeline. By help of callbacks, we can stream answers token by token to UI, track API cost, debug where exactly the error occurred, all those things. Here we have a logging callback handler. In this we have on LLM start, on LLM end, on chain error, and we are requesting an input and printing the response. If you check here, when LLM started, it is printing the configured things like the prompt preview. It is able to print the prompt. When LLM finished, it is able to print the tokens used. This is how we can use callbacks to monitor our application. Conversational retrieval chain versus retrieval QA. Which do you use for chatbot? Retrieval QA is just answers one thing and forgets it. It only takes one input and provides one response and forgets everything. But coming to conversational retrieval chain, it stores the entire session and it remembers everything in the context. This is a in-memory vector store, and we are configuring the vector store here. And when we ask the first question, tell me about Earth, it is printing the response that Earth is a planet with a radius of approximately 6,371 kilometers. In the second question, we are only mentioning about radius, not any details about Earth. But still, it was able to identify it as Earth and it gave the response. In the vector store, we have three planets: Earth, Mars, Jupiter. When we are asking for radius, it might be referred to these three planets, but still it gave response related to Earth because it has the context, it stores the context and it used the context to provide the second response. What problem does self query retriever solve for user queries? In standard vector search, it only retrieves the near mathematically near values. Coming to self retriever, it does both. It does semantic search and metadata search. It act as the metadata search act as where clause in SQL. Here we have sample records with metadata. We are configuring vector store. Metadata fields for LLM. When we ask to find sci-fi movies by Nolan, what it does is it tries to do semantic search of sci-fi movies by Nolan, and in the response it is providing the desired output. How does runnable pass-through work in LangChain Expression Language, and why does RAG need it? What runnable pass-through does is it passes the exact same question unchanged, untouched throughout the retrieval process. So we won't lose any data. Here we are creating in-memory vector database, and here we are using runnable pass-through for question. As we are using runnable pass-through, this question will be passed exactly throughout the retrieval process without changing, and it provides the response. It will be useful where we have complex steps and complex processes. what LLM usually does is, if the context window is huge, it forgets the things and it hallucinates. So if we are using runnable pass through, the question will be unchanged and LLM will be able to provide the accurate responses. Can you explain the React pattern used under the hood of LangChain agents? React pattern is nothing but, first it generates thought, then it takes action on the thought, and it observes whether it generated proper response or not. In the example, we have a calculator tool. In the input, we are trying to perform calculations. First, LLM has to multiply these two things and get the value. Once it got the value, again it has to add with 230 and it has to provide the response. It's not a single step process. First, it is generating the thought, it is taking the action, and it is observing. It will be in the loop until it gets the desired output. Why is conversational token buffer memory considered the best choice for production chatbots? Generally, the context window is limited. When the context size grows, we have to reduce it or else it will crashes. We have two options. Either we have to summarize the entire context to the shorter text, or we have to remove some of the data from the context. What conversational token buffer memory does is, it has a limit of some tokens. Once it reaches this particular limit, it forgets the older messages and keeps the context flowing. If we use conversational token buffer memory, we can specify the token limit, and once the context window reaches the specified token limit, it removes the oldest messages so that the context has a memory for new data. Here we are defining the conversational token buffer memory and the token limit is 500. Here we are having multiple conversations with LLM so that memory buffer increases. Once it reaches max token limit, what it does is, it forgets this message, the first message. In the output, if we check, we only have one conversation, that is which is the best for production, the last conversation. It forgot about two conversation because it reached the token limit. There is a disadvantage for this because we might lose the context and we might not get the desired output. If we use summarization technique, we are able to store the context, but it's an additional API call and we get cost for this. Here we have to pick the right trade-off for our applications. If the context is important, we have to use summarization. If context is not important, we can use a token buffer memory. Thank you.